Okay, that's our 30 seconds. So we're going to go over them together, and then we're going to pass them up. I am going to give you a grade. So let's look at number 1. Make it a little bigger. All right, so the diagram is not actually below. It's to the right. It says points FC, B, and A, line and plane X. So that's the name of this plane, or that's one name of this plane. The first question is to give me another name for that plane. So what's another name for that plane, Miriam? ABF would be exactly correct. No commas in between. A, B, and F. Did anybody say ABC? Okay, so be careful because ABC are all 3 collinear. You can't have all 3 points in a line. So if she said ABF, you could say BCF. But you can't give ABC because it doesn't belong to just that one plane, right? There are other planes that are intersect at that line. So if you did ABC, really that's the only ones you cannot say. You cannot say not a plane ABC because they are all 3 collinear. B, point A and 3 of the points are distinct points that are coplanar. I think yesterday I gave you the impression that you could not say that points on the line are coplanar. Points ABC are coplanar points. You just can't name the plane by that, okay? So A, B, C, and F, they only give us 4 points here. So the only option is A, B, C, and F. Great question. It does not. C. Some point and point C are distinct points that are collinear. What do you get for C, Jessica? A would be great. Is there another correct answer? Very good. So A or B. Line ED and some other lines are distinct lines that intersect. Very good. Line BC. You could name that line AD or line AC as well. But it is this line and this line intersect at point B. Questions? So just keep in mind, sometimes I will collect these before we go over them, so they should be complete when you're going over them. And I'm actually going to stop right there because I ran out of time, almost ran out of time in third period. I want to make sure we don't run out of time for notes today. So let's go ahead and does anybody have questions on this one? Anybody have questions on this one? I'll go through real quick and give you answers. So you guys look at yours and see. So for A, it's going to be point X, Z, and T. For B, it's going to be line QT and line XZ are intersect. We could also name that XY or YZ or reverse the order of those. For C, another plane for line P. There's going to be any 3 points, but remember, not XYZ. It could be XYT, XYR, YZR, right? Any of those. So we're going to say YZR, and then the 2 points that are collinear with X. So it could be Y and X or Z and X. Does anybody have questions on problem 2? All right. Open your Chromebook up and pull up yesterday's assignment real quick. This is where we ask questions on yesterday's assignment. Go ahead and pass up your warm-up, I'll select them. Pass up your warm-up, I'll select them. Make sure your name is on them. Go ahead and pull up your assignment from yesterday. That's the 1-2 on Alex. Is anybody that was absent yesterday? Anybody that was absent yesterday? So we're pulling up 1-2 on Alex. And even though it's digital, you can still scroll through and let me know if you have a question or any of your problems. Remember that you can can complete this assignment as many times as you need to get the score that you want. So you can do it as many times as it takes to get a 100. Keeping in mind that you don't have to redo the entire assignment each time. If there are 10 questions and you miss 8, and you do a retake, it's only going to give you the 2 you missed. Right? If you get one of those correct and you do another retake, it's only going to give you a different version of the one you missed. You can keep doing that until you get a 100, but it's not quite as much work as it sounds. Does that make sense to everyone? Does anybody have a question on yesterday's assignment? So it looked very, not all parts of it, but this was a big part of your assignment from yesterday, so that warm-up was. Anybody? Questions on anything from yesterday's assignment? So remember, I don't know what you need help on if you don't ask. The way you know what you need help on, even if you got them all right, what was the problem that you had to do 3 times maybe? Sometimes there's one that's harder than the others to do, and so that's the one you want to ask about, even maybe if you eventually got it right. Ms. Zimmerman, how do I know, or how can I do, or I keep making this mistake. Can you give me some suggestions on what to do differently? Those are the kind of questions you can ask, even if you wind up finally getting it right. Does that make sense, Aiden? Okay, both Aidens. Wow, 2 for 1 right there. Get 2 for more bang for my buck if I ask Aiden. All right, great. Okay, we are going to go ahead and get started on today's notes, and I think they're a little bit, they printed weird, so I got to regroup on that. But I'm going to be just, it's going to be just fine. We are going to go ahead and get started. Like I said, I ran kind of short on time last period. To be fair, they did not do as good a job on getting started on their warm-up as y'all did. So, good job on you. We should have a little bit more time. Yeah. Okay. Yeah, the notes are a little bit out of order, but I got it now, so I'll redirect you when it comes to it. All right, measuring segments. Telling how long segments are. That's what that means, right? How long is a segment? Or, in our case, remember a segment is a part of a line, right? The first thing we're going to start with is measuring distance on a number line. No, that's the wrong one. On me, that's the right one. Okay, I was wondering. All right. Segment addition, the segment addition postulate. That sounds pretty complicated, doesn't it? Segment addition postulate. You know what that is? You tell me if you understand this concept. All agree that's segment AB? All right. We're going to call that point C. From A to C is 4. From C to B is 6. How long is AB? That's a segment addition postulate. Right, so it sounds really hard. This one is kind of a captain obvious thing. So AB is 10. So all the segment addition postulate says that anytime you have a segment, if you split it with another point, the sum of the segments that you create equal the length of the segment, right? So we started with AB, we stuck another point in there. We know this is 4, we know this is 6, so we know the whole thing is 10. It makes sense, right? This length plus this length has the length equal the length of the whole thing. You all knew that before I said it, right? The other way we apply this is, what if they tell us that the whole thing is 10? Can we find out what this length is? What do we do? Right. Right. And the way we can do that is just subtract the whole minus the part. Right? So that's what we're doing today. Well, that's one of the things we're doing today. Okay? So we're going to go ahead and get started. it gives you the postulate here. And the confusing explanation is that 3 points are collinear and B is between A and C, then AB plus BC equals AC. So all that is the same as that little example we did on the left. Go ahead and close your Chromebooks if you still have them out. We should all be on our notes with me right now. I want you to keep them out. I'm very optimistic, not hopeful that we'll have time to start our homework, but who knows, it could happen. All right, so looking at example 1, you're going to label your diagram, label your figure. What does it mean? What does xy equals 14 mean, Sophia? That's so great. That's so great. So remember, nope. Remember on yesterday's notes? We said this is segment PQ. You're not writing this, but this is yesterday's note. We said this is segment PQ, but if you write it without that segment, where they're asking the length or the distance between those 2 points, the length of segment PQ or the distance between point P and Q. So Sophia is exactly right. Where do we think we are? I can't see. Okay, so we're going to label XY is 14. YZ is 9. What is the length, or what is the distance between points X and Z? We just add them, right? So we know that length is 23. Example 2, they tell us the length, the distance between points A and B is 6. The distance between points A and C are 11. They want us to find BC. So 6 plus what equals 11? 5. And if it's not a fact that you already know, you just subtract. The whole minus the part gives us the other part. Okay? The whole minus the part gives us the other part. All right? Go ahead and label your figure. Always start by labeling our figure. In the figure below, AC is 25. BC is 16. They asked us to find the length between, or the distance between points A and B. Whole minus the part here. They gave us the whole, and they gave us one part. So 25 minus 16. We know the length between points A and B is 9. Questions? Just subtract. We should have calculator behind you there. All right, the next thing we're going to talk about is finding the distance between 2 points on a number line. So, if you can see the 2 points on the number line, one of the ways is just to count the distance between them. Does that make sense? We want to know the distance between point E and point F. Point E is at 1 on the number line, point F is at 12. We can just count, right? So it's 11 units between 1 and 12. But there's also a formula, and you should be able to use both, because they might not give you the number line, right? They might give you big numbers. It would be too lengthy, too time-consuming to draw the number line and count. So to find the distance on a number line, we can also use a formula, and that is the absolute value of the difference of the coordinates. So remember, difference means to subtract. And in formula form, it's going to look like this. Remember, these vertical lines are absolute value symbols. And I just use P sub 1 for point 1, P sub 2, right? It does not matter. We could call this P sub 1 and this P sub 2 or vice versa. That doesn't matter. So we're going to plug into that formula. E is 1, F is 12, so we're subtracting them and taking the absolute value. So the one thing that your calculator won't do is find the absolute value. Oh, I'm sure there's other things, so that is one thing that comes to mind. I don't know how to find the absolute value in there. So remember what the definition of absolute value is. Absolute value is the distance from 0 on the number line. So once I use my calculator, I'm going to find that the distance is the absolute value of negative 11, and that means we tell them how far is negative 11 from 0, where it's always going to be a positive number. Whether that's the absolute value of negative 11 or the absolute value of positive 11, they're both 11 units from 0. So that would be the distance on the number line. So they've labeled point C, they've labeled point D. We're going to plug it into our formula. Use your calculator. Remember, it's got a negative button on it or an opposite button on it. So 3 plus minus button minus 9, you should get negative 12. So it's the absolute value of negative 12. If you give the answer as negative 12, it's wrong, right? So how far is negative 12 from 0? The absolute value of negative 12 is 12. You guys go ahead and do example 6. So you're going to go ahead and write it in the absolute, write the subtraction problem in the absolute value symbol. You listening, Sam? Daniel, when you write it in there, buddy? Let me see. Did you write it? Example 6, what did you write? Give yourself 2 absolute values like I did. All right? And what's the subtraction problem you're going to put in there? It's your points that they have dots on. So they mark the points of those dots on the number line. So we're going to subtract those, right? So it's negative 12 minus negative 2. So be careful. It's not minus positive 2. On your calculator, 12 plus minus button minus 2 plus minus button is equals. You should get the absolute value of negative 10. And so the absolute value of negative 10, how far is it from 0? It's 10 units from 0. Your answer, if they ask you to find the distance, has to always be a positive number. Sophia? So it's minus negative 2, right? Because this is a negative 12, and this is a negative 2. So if you subtract the negative, it's a positive, right? So do it on your calculator to double check that mistake, because that's a very common mistake. Negative 2. Yep. Yeah, because you didn't enter it on your calculator. So 12 negative, 12 negative minus 2 negative equals negative 10. Yeah, you got to do minus, then 2, then the negative button.
So even if it's already negative, we still have to put subtraction.
Yes. So, yes, exactly right. It's always subtraction. Remember the definition was a difference. Difference means to subtract. So if we look back up at our definition, we're finding the definition of the distance on a number line, it says that we are subtracting. When it says you find the difference, remember the sum is the answer to addition problem. A difference is the answer to a subtraction problem. So we always have to subtract them no matter what their sign. Great question. Anybody else? All right, we're moving on to 6. So we know how to find the distance, how far it is between M and P on the, for example, 7. But how do we find the point that's in the middle? So midpoint just means the middle point. The middle point between those 2 points that are marked on the number line. Well, we could count, once again. We could count from 1 to 11, figure out how that distance, and then we could split it, right? But there's also a formula. The first thing we're going to define what the midpoint number line is. So the midpoint is not a length. The midpoint is an actual number on the number line. So when you're finding the midpoint, it could be a negative number because you're not finding distance or length now. You're finding out which point is exactly between those 2 points. Which point has the same distance before it and after it to points M and P. So between M and P is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it's 10 long, the middle point is going to be 5 from either end. Does that make sense? So I can go 1, 2, 3, 4, 5. So I know my answer should be 6. The midpoint, the point that's in the middle of those 2 endpoints is 6, right? So we're going to use a formula for that. You should be able to do it either way. But once again, sometimes they're not going to provide you the number line. Sometimes that number line would have to be too big for you to have time to do it. So we're going to use this formula. Point 1 plus point 2 divided by 2. No absolute value symbols. This is not a distance problem. So we can call M.1 and P.2, or vice versa. That order doesn't matter because we're adding those. So let's plug into our formula. M is 1 plus P is 11, and we divide by 2. So when you're doing this on your calculator, you add 1 plus 11, then hit the equals button, then do divide by 12. Divide by 2. Thank you. So 12 divided by 2 is 6. And that's what we said it was, right? So that's the midpoint between point M and point P. We counted and found it. Austin, do you need to stand up, ready? Are you okay? Questions? All right, what's the midpoint between points A and C? Doesn't matter which one you designate, and I don't care if you write P1 and P2 over them. Just for these first couple, I'm doing that to make sure you understand what we're doing. We take what is the location of point A? It's at -3. The location of point C, that's at +11, and we divide by 2. So A divided by 2 is 4. So now we know that this midpoint, so that is the midpoint. That is the midpoint. Let's box that so when you're reading your notes, you'll know that that is the answer. You got to see number 9. What'd you get, Raiden? What'd you get? -4. What'd you get, Billy? -5. What'd you get, Raylan? -5. So we got 2 -5. So let's do it together. So M is -9 plus P, which is -1, all over 2. Add our negatives, right? So 9 plus minus button on the calculator plus 1 plus or minus on the calculator is -10 divided by 2. You see the difference, Braden? So if I had to guess, I'd say either you didn't use your calculator or you didn't put the negative for that one behind it. Does that make sense? So be careful about that. So the midpoint is -5. All right, any questions? All right, we're going to talk about these two first. They're a little bit out of order. So let's talk about what it means to be congruent and what is a segment bisector. Congruent figures. Congruent is another word for equal, but we don't use equal unless we're talking about numerical length, right? If we want to say that segment AB and segment XY have the same length, we're going to say they're congruent. We don't have any numerical values there, right? So the way that we mark on our figures in geometry when things are congruent is we use these little hash marks. So if segment AB and segment XY have two little hash marks on them, now we don't know how long they are, Anthony, but we know they're the same length, right? Let's say I had another segment here. Let's say I had segment WD. And it has one dash on it. I don't know what any of them measure. I don't know which ones are shorter or longer. But I know these two have the same length, and this one's different. Does that make sense? Okay. And then a segment bisector. Anybody know what it means to bisect something? The big prefix. What's the prefix? What does bi mean? Two. What is a sector? A part of something. A sector or a section, right? So we're going to split it into two equal sections. If it's a bisector, whether it's a line, a plane, a ray, a segment, anything that splits something out into two equal parts is a bisector. So if it's bisecting a segment, then it's a segment bisector. So this line, SR, is bisecting this segment. This segment can't bisect this line. Why not? Why can't the segment bisect the line? How long is the line? How long is any line? Infinite, right? So you can't bisect something that goes on forever. So this line, SR, is bisecting segment PQ. Does that make sense? And we know it's bisecting even if they don't tell us, because they mark PQ has one hash or dash, and RQ has one dash. So we don't know how long they are, but we know R is the midpoint, and we know this length and this length are the same. Okay? So go back. In the figure below. So it's important on these kind of things that we're marking our figures. They sound a lot more confusing than they are if you've not marked your figure with a given thing. So, in this figure, S is between Q and T. We see that, right? Nothing to mark there. They don't tell us anything else, but we see that. It tells us that R is the midpoint of segment QS. So segment QS is here, and this is the midpoint of QS. What does that mean about QR and SR? If this is the middle point, what do we know about the length from here to here and the length from here to here? They're the same. They're congruent in geometry, right? So we're going to mark those with a hash. The next thing, so they gave us no numbers there, but now we know something about parts of this segment. And these are going to take us back to that segment addition postulate. So just a little different variation on that. A little bit more complicated. All right, now it says that RS is 7. If RS is 7, how long is QR? 7, right? We've marked them. They're congruent. This is the midpoint between Q and S. So if this is 7, then this has to be 7. Are you with me, Ethan? Okay. And the last thing it tells us that RT is 13. So from here to here, is 13. They want us to tell them the length between, the distance between points Q and T. I don't know that yet, but if I know FT, won't I know that? Does that make sense, Jada? If I know how long S and T is, can I find out how long the whole thing is? I know this part is 7, this part is 7. If I know how long this part is, I can just add it all together, right? All right? Austin, how can we figure out how long this part is? It's not 7. It's not congruent, right? We didn't mark that. They don't tell us that they're the same length. What do you think, Naomi? How can we find the length of segment FT? Brandon? 5. How'd you get 5? Okay, so Brandon is on the right track. But 7 plus 5 is 13. 7 plus 6 is 13. So Brandon, the concept he's got, right? If we write a second little segment over here, let's say that this, you don't have to write this, just watch. We know R and T, and we know from here to here is 7, and we know from here to here is 13. Don't y'all know that the whole minus the part with that part, right? So just because it's squished in with that other segment, it's the same concept. Okay? Good job. So now we know that 13 minus 7 is ST. Now to find QT, it's 7 plus 7 plus 6, which is 13. It's the same thing that we've added a little extra part to it. Freeman, you good, honey? Any questions? All right. Let's go ahead and mark our figure for 11. You guys try to mark the figure. See if you can mark the figure in example 11. I think this is our last one. It says that O is between M and P, nothing wrong with you there. No, it says M is between O and P. It says M is a midpoint, so this is where we start marking stuff. This is where we start marking stuff. If we know N is a midpoint between M and O, we should be able to mark something, right? It's not just 5, right? This side and this side, right? Oh, right. Right. Alright, so be careful. This is 5 and this is 5, right? So marking these congruent. So if you know this is 5 and this is 5, 16 minus what? Mm-hmm. Good. This is clearly 5, right? This is 5. Okay, so this is 5 and this is 5, right? So the whole thing is 16. Yeah. So, I need to see a little bit more work. If you only wrote the answer, go ahead and fill in with my work. I need to see that you know the N to N, the midpoint, and that the length of MN and the length of NO are congruent, right? So the little hash there, so just put a hash, put your hash in, right? We need to mark that NO is 5. And most everybody I looked at had that correct. They didn't always have the congruent marks. But they had 5 and 5. Everybody I looked at had the whole thing, MP. labeled as 16, which is correct. But over half the people, if it's 16 minus 5, gives me the length of OP. So be careful. This is 5 and this is 5, right? So this plus this equals 16. So when you're taking the whole and subtracting the parts or parts, so in this case we have 2 parts we have to subtract, right? And they're the same. So we can subtract 2 times 5, which is 16 minus 10, which would tell us that OP is 6. Good job. So what you got, Chloe? So what you got, Dylan? Did you mark it? All right. Well, there's 2 sides here, right? So we could have just done, instead of 16 minus 3 times 5, we could have done 16 minus 5 minus 5 equals 6. Okay? If we have to subtract all the parts to get the part we're looking for. In our earlier example, there was only 2 parts, right? The whole minus part gave us the missing part. Okay. So we knew that RS was 7, right? And they told us that RT is 15. So if we know, so this is like a segment in the segment, right? So right now we're not looking at this part, we're just looking at this part of the segment. That's why I drew it over here. Because we look at just this part of the segment to find out how long is ST? Well, we know the whole is 13. We know the part is 7. So the whole minus the part equals our other part, right? So 13 minus that 7 tells us that this length is 6. Cool. If you're done, you can scan and submit your notes and go ahead and get started on your assignment, 1-3 in Alice, and make sure you have something to write on or write with. Okay, so give me a second. Go ahead and scan and submit your homework, go ahead and get your Chromebook open, get your assignment pulled out. Yep, scan and submit that on campus. 7 plus 7 plus 6. Okay. So we figured out they told us that this one is 7, right, David? And because this is the midpoint between here and here, then we know that this one is 7, right? So we know that this whole length is 7 plus 7 plus something, right? That's our unknown. But then we found our unknown, right? Because they told us that RT is 13 altogether, right? So we're just looking at this part of our segment now. So if this part is 13, and the part of that is 7, now we know 13 minus 7 gives us the third part of 6. Right? So now we know it's 7 plus 7, and the third part we didn't know is 6. So this segment, the length of this whole segment is equal to the sum of its parts. Okay? Cool. Exactly. Chloe? Oh, it's supposed to be 20. Thank you. That's what's confusing everybody. Happy now. I do that sometimes. I don't know why. Y'all text me earlier because I confused everybody when my brain goes haywire. Yeah, that's definitely 20. No wonder it was confused. My bad. Everybody stop what you're doing and correct that 7 plus 7 plus 6 is not 13, but it's 20. 7 plus 7 plus 6 is 20. I really can't add, no, I don't always do it without mistake. I get ahead of myself, moving on to the next thing sometimes. Thanks for correcting me. If you did not correct that 7 plus 7 plus 6 equals 20. I do know, now I see why it was so confusing, the math wasn't mathing.